let's take a few minutes and summarize, all the equations and all the values that we have. One of the primary things we deal with is complex power, and complex power is both its real power and the reactive power. And our real power, so our average power, is going to be the real components of the complex power, which is going to be equal to VRMS IRMS cosine of the voltage phase minus the current phase, which is the same thing as IRMS squared times R. And when we talk about power factor, that is also represented as phi z. So we've got one set of equations here. Another set of equations is that our reactive power, so Q is going to be the imaginary component of the complex power, and that is going to be VRMS IRMS, and then the difference here is that this is the sign of the difference between those two phases, and just in the same way this will also be called phi of z, and this can be equal to IRMS squared times x, where x is the reactive components of some load. So if you have some sort of load that is z, then that z load has a real component and also a reactive component. Finally, we also talked about S, and S is the magnitude of the complex power. So this is the magnitude of the complex power. This was equal to the square root of the average power plus the reactive power, both of them squared. And that's the same thing as VRMS IRMS, which is also the same thing as IRMS, let me get that one down, IRMS squared times the magnitude of that, whatever that Z load is. So if this is Z, that is the same sort of Z. Finally, we have our power factor. So our power factor was the average power over the apparent power. And there are a couple ways we can rearrange this by simply saying that that relationship, given our power triangle, is the cosine of the two phases of the voltage and the current, which again we keep calling Z. So there are bunches and bunches of different expressions and equations for all of our quantities in here, and when you do a homework or when you have an exam, I will give you a sheet that has all these relationships. I don't want to put them in here because I don't necessarily want to violate copyright and put it up on YouTube, but all of these expressions we're going to need to understand all these different quantities. And one of the real challenges within complex power and AC power is just trying to keep straight all these different values, like which R and which X and which S are we talking about, to try to figure out all of these quantities. So make sure that you understand what all of these values are before we calculate all of these different entities. So again, here this is our real power, and real power is always in watts. This is our reactive power, and this is always in VARs, volts, amps, reactive. Our power factor is unitless, and then our apparent power, which is just again kind of the resultant of the complex power, is in volt amps. So everything's going to have slightly different units: volt amps for apparent power, watts for real power, and VARs for our reactive power.